we summarize the things that we have discussed under equations of motion and the linear momentum and angular momentum. So in this portion, in this part of our discussion, we learned and we discussed Newton's laws of motion, the three Newton's laws, the famous three laws of motion in solid body as well as in the fluid dynamics, whereby how do they act on the fluids. So similar things are taken into consideration as the fluid flow takes place. Choosing a control volume, forces acting on a control volume. So we have to pick up a random control volume on which the forces that are acting are to be considered. The linear momentum and the linear momentum equation that are generated thereof, they are special cases, and when we talk of special cases, obviously we mean whether the motion is steady, it's non-steady, or whatever extra assumption can be applied sometimes to simplify the question and consider a specialized case of general motion that may be occurring. When the general motion is occurring, we have to consider all the parameters related to that particular situation. But in special cases, by making those assumptions, we simplify our problems. And of course, the solution that will be generated will reflect those assumptions. Similarly, we considered momentum flux correction factor beta, steady flow with no external forces. We reviewed rotational motion and angular momentum, which is very much similar to linear momentum, but with slight variation and have rotational effect, and torque also comes into place. The angular momentum equation, and similarly, like the linear motion, we consider here the special cases that are relevant to this, and flow with no external moments, and the radial flow devices such as centrifugal pumps and sprinkler and so on.